Okay, let's keep going. Before the break, we talk about the ionic bond. Now let's look at the second kind of bond. It's called the covalent bond. Definition of covalent bond. Covalent bond is electron sharing. They share electron. Okay, let's look at the example. Example, hydrogen. Okay, hydrogen atomic number is 1, means 1 proton, 1 electron. And when you have two hydrogen together, hydrogen's outside layer is a small shell. So it can accommodate 2, and you want to accommodate 2. So each one of them only has 1 electrons. They want to have 2. So now you put 2 hydrogen together. The one on the left want to have 2. The one on the right want to have 2 as well. And they fight, they are equal size. So eventually they put their electron in the center and share. So for the atom on the left, it looks like he has 2. He's happy. Happy means low energy. For the one on the right, it looks like he has 2. He's happy as well. So this kind of electron sharing, different from ionic bond. Ionic bond is 100% given away, and this one is electron sharing. And we can look at oxygen. Oxygen's valence is 6. Atomic number is 8. 8, so 8 proton, 8 electron. So first layer you have 2, second layer you have 6 electron. You need to have 8, so you need to share twice. You need to share 2 electrons. And you share with another oxygens. So they share 2 pairs of electrons. That's covalent bond. And for carbon, carbon's atomic number is 6. So 6 proton, 6 electron. First layer, you have 2. Second layer, you have 4. And carbon, he needs 4 more to make the carbon happy. Happy means low energy. So you need to share 4 pairs of electron. And that's covalent bond. So you find in the chemicals representation, they use the dash line to represent the covalent bond. So 1 dash line means 1 pair of sharing. And for the oxygen, they share 2 pairs. You find 2 dash line, 2 dash line. And of course, this kind of covalent bond is twice stronger than this, than the single covalent bond. And carbon, it can share 4. So he has 2 share with oxygen, 2 share with another oxygen. That's covalent bond. So definition of covalent bond is electron sharing. It's another strong bond. It's another strong bond. Ionic bond is also strong. So which one is stronger? Sometimes the textbooks say covalent bond is stronger. But I also read a few textbooks. I have several textbooks in my office. They say ionic bond is stronger. So definitely both of them are strong bond. So I put here they're stronger than ionic bond means most books say covalent bond is stronger. But covalent bond, remember, they can share twice or they can share 3 pairs of electrons. So when you have a triple covalent bond, definitely is stronger compared with the ionic bond. So in the test, I give you double covalent bond, ionic bond, and the next one, hydrogen bond. You know, definitely the double covalent bond is strongest one. So that's covalent bond, electron sharing. And they can share more than 1 because they want to steal the octet rule. They want the valence electrons to follow the octet rule, which is the first layer is 2, second layer is 8, third layer is 8. And I won't ask you more than third layer, right? Okay, so you can have found a more multiple covalent bond. That's why they're stronger. You have a double covalent bond or triple covalent bond. So they can share those electrons twice, 2 pairs, or 3 triple covalent bond. And it become a very, very strong bond. It's like you have a super glue and use 3 times. So it's much stronger. And covalent bond is very important for the biological molecules because in the next few lectures, when we talk about the biomolecules, lipid, this is lipid, and protein, amino acid, they all use covalent bond to form the big molecule. It's like a Lego. use covalent bond to build up a big Lego. And covalent bond has a very unique characteristic. Okay, they share electrons. So far, we talk about they share equally, but they don't have to share equally. The reason is we have some atoms that are bigger than the other, like the oxygen. Oxygen atomic number is 8, so it's 8 times bigger than hydrogen. So when you have oxygens 8 times bigger than hydrogen, they share electron. They won't put electron in the center. The oxygen will pull electron much closer to the oxygen head because they're 8 times bigger than the hydrogen. And when they share electron together, the electron has negative charge. So when the electron become closer to the oxygen side is partially negative. And they use the Greek number delta to represent it. So delta negative means a little bit negative. And the hydrogen side is a little bit positive. And we call this electronegativity. When two atoms, they have different electronegativity. Electronegativity means the power they are able to pull electrons. They are different, and the electrons are not equally shared. And a good example is water, H2O. So the oxygen will pull electron much closer. So the oxygen side is partially negative. Hydrogen side is partially positive. And that's why water, we have one lecture specifically talk about water. Water is a perfect solvent. It dissolves a lot of solute. Solute is a molecule dissolved in water. And the reason is, well, water is polar. So these kind of molecules, we call them polar molecule because the electrons are not equally shared. And this covalent bond is called polar covalent bond. Polar covalent bond. And when you have the polar molecule, well, sodium chloride, they like to stay in the ion state. And then no matter you have the cation, which is positive charge, or anion is negative charge, water will always find a way to surround it because water has one head partially negative and the hydrogen partially positive. You just, well, no matter which ion, they can use the head or use the hydrogens to face it. So they become a perfect solution. Water become a perfect solution. Okay. And the third bond we're going to talk about is called the hydrogen bond. This one is different. The other two bond, electron, they're inside the molecule, like the ionic bond, covalent bond, they're inside the molecule. Hydrogen bond is between molecule, between a water and another water. So you find covalent bond is within water molecule itself. But hydrogen bond is between a water and another water. The reason is you have a water, the head is partially negative, the oxygen part, and the tail is partially positive, the hydrogen part, they will attract each other. But they are only partially positive and partially negative. So this kind of bond is definitely weaker. So hydrogen bond is a weak bond. It doesn't have to be water. When you have a polar covalent bond exist in the molecule, this molecule become a polar molecule, and this polar molecule will attract another polar molecule. So hydrogen bond can happen, most common one is water, but it can happen also in oxygens, fluorine or nitrogens, they share, they bind with hydrogen. They can happen in that as well, hydrogen bond. But most convenient, most common one is water. Especially water is a very important molecule in biology. So we keep using water as example. So hydrogen bond, this one is between molecule. In the water and another water, you have positive charge, negative charge, they attract each other. And this is much weaker. That's why they use the dash line. Dash line means it's not solid line. Means it's a weaker bond. And this is like a weak magnet. If you think the ionic bond and covalent bond, they're strong magnet. You purchase those strong magnet to glue together. And this will be the weak magnet. Nobody want to use it today, but they still attract each other. So hydrogen bond is between molecule. It's weaker. It's weaker is not bad because it's weaker you can break it. Like water, okay, they attract each other. So water have a big surface tension because of hydrogen bond. And the other molecules, we will talk about them, like the DNA is double helix. This is RNA, single strand. You find the dash line. You see the dash line here. You see the dash line here. So you know they're actually hydrogen bond. And hydrogen bond being used in biomolecule a lot because they're weak bond. So I call them sticker nodes. So if you purchase those 3M sticker nodes, uh, uh, you find you can stick it, you can take it away, you can stick it back, and that's the hydrogen bond. Because they are weak bond, so you can split them open like this double helix DNA structure. You can actually split it open. It's a weak bond, so it does not take that much energy to break it. So we definitely can break it. And DNA is very stable because it's double helix, so the weak structure is protected inside. And then it's very stable. You find those, if you like CSI, they actually find the DNA in the crime scene. So DNA is very stable. Or you find the DNA of the fossil dinosaur. They are very stable. The reason is the weak structure is protected. But if you need to use it, you can split it open. So when we said we will talk about the DNA transcription. When you need to use it, you can split it open. You can use the one string and you use it. And after you're done, you glue them back, protect them. So this is the advantage of the weak bond. You can break it and then you can glue them together. And RNA have those hydrogen bound. You can maintain those 3D structure so they can glue together. And the hydrogen bond become a very useful bond for the biological system because it's weak. You can break it and you can glue it back. So we talk about three kinds of bonds: ionic bond, covalent bond. Both of them are strong bond. And then we add a hydrogen bond, which is a weak bond. And hydrogen bond is between molecule. Ionic bond and covalent bond, they are within a molecule. Okay, let's stop here.